Hi, everyone. This is Ben Jones at Data Literacy. I'm going to deliver a presentation today where I talk about mistakes people make when they create charts and graphs, and also, therefore, mistakes others make when they try to read and interpret said charts and graphs. So the presentation is Learning to See Data, the Graphical Gaffes edition. And so this is based on a few things. Well, we have a course at my company, Data Literacy, where we teach people how to learn to see data. This is our team, by the way. That's me in the middle there. My wife, Becky, on the left side of the photograph. Megan Hanno, our operations manager, on the right side of the photograph. Really proud of the small but mighty team and the way we're helping people to speak the language of data. As I mentioned, this topic of being a fluent chart reader is so important. I mean, we just encounter charts every single day now. And so in 2019, I published a book through John Wiley and Sons called Avoiding Data Pitfalls, where I talk about this. And then more recently, we've published Learning to See Data, and that's also related to our Data Literacy Level 1 course of that same name, Learning to See Data. Now, that book and course was inspired by three fabulously talented women in the data visualization world. Tamara Munzner, she's at the University of British Columbia up in Vancouver, and she wrote a classic textbook published in 2014 called Visualization, Analysis, and Design. Another book that really inspired me as I created that book and course is Mind in Motion by Barbara Tversky. Now, she teaches at Stanford and NYU. This is all about how we use our minds when we encounter time and space and how we think through different situations in life. And that very much relates to charts and how we see them and how we understand what they're representing. And then lastly, a book that was written back in 1969 by the late Mary Eleanor Spear. She was an American information graphics specialist who worked for the federal government for decades. She lived and worked at the time when all of this needed to be done by hand. And so I have a lot of respect for her and those in her generation. And her book, Practical Charting Techniques, was very inspirational for me as well. Specifically this quote, which forms the inspiration behind the course. She says in that book, learn to see details. There's quite a difference between simply looking at a chart and seeing it. Looking is your first visual impression, while seeing involves the studying of distinct parts of the visual. And we're going to do that today. That's going to be our focus. We'll look at a number of charts and we'll try to look closely at them to see past our first reaction. It's important for me to state up front that, we are going to be humble as we go through, recognizing that we ourselves have created charts with many, many mistakes in them, and we'll continue to do so. While we may allow ourselves a moment to chuckle at a silly chart, there's no need to mock, and we'll stop short of that. We'll also be dealing with topics that are political and sensitive in nature in the visualizations themselves. Most of them are fairly recent. Some of them are a little older, but in any case, the desire is to really understand the communication mechanism of the chart, less so maybe necessarily covering the sensitive issue itself. That being said, there is one chart that deals with a very upsetting topic, and I want to pause for a moment when we get there to really recognize that we can't simply look at statistics about death and suffering without understanding that there is a very real human cost in it as well. Okay, so that out of the way, we'll keep that in mind. Here's something kind of silly and lighthearted to begin with. So a lot of learning what to do can be informed by seeing examples that show us what not to do. And sometimes it can be very small details. For example, the difference between these two sentences would give a very different reaction, perhaps, by your grandfather. Let's eat grandpa, or let's eat, comma, grandpa. Those are totally different sentences with very different meanings. Additionally, inclusion of a comma can change a nice fuzzy creature we see at the zoo into a deadly bar patron. And that is either describing the way a koala goes about eating in a restaurant or simply what they eat off of a tree. Okay, so little details can make a huge difference. I love this example. This is a love letter, right, to start off with. I'll read it out because it's fun to read. Dear John, I want a man who knows what love is all about. You are generous, kind, thoughtful, People who are not like you admit to being useless and inferior. You have ruined me for other men. I yearn for you. I have no feelings whatsoever when we're apart. I can be forever happy. Will you let me be yours, Jane? Okay, same words, very different meaning. A cease and desist letter to John. Dear John, I want a man who knows what love is. All about you are generous, kind, thoughtful people who are not like you. Admit to being useless and inferior. You have ruined me. For other men, I yearn. For you, I have no feelings whatsoever. When we're apart, I can be forever happy. Will you let me be yours, Jane? So, small punctuation, big difference in message. It's the same with charts, as we're going to see. Some of the issues and the miscommunications that happen in the examples we'll talk about come down to very small details that can really have a huge influence on the way people see and what they take from what they're looking at. And so this is an important part of data literacy, what we believe is critical for us as a species right now on this planet to focus on this, make strides, help people become more confident and more fluent in this language of data, specifically today, focusing on the visual language of data. We're going to go through 4 categories, okay? And within each one, there'll be a handful of examples. First one is type number 1. We'll title this one, A Confusing Chart Walked into a Bar. Okay, so bars are commonly skewed in data visualizations, leading to confusing or misleading outcomes for the interpreter. For example, this one that seems to indicate that the number of unvaccinated American adults plummeted by more than half from one point to another. As you can see, though, if you look at the labels, that there's 95 million in the bar on the left and then 67 million in the bar on the right. If we were to just even slap that together into a simple Excel chart here, accepting all the poor defaults, we can see what that change would really look like. So clearly not declining by 50%. But this is a very common mistake. And, we see it all the time. People love to talk about it. People love to point it out anytime they see it. And it can almost be a knee-jerk reaction. Anytime we see the y-axis, if you look at it on the left very carefully, you can see that it does not go down to 0. This means the bar we're only looking at the tops of those 2 bars. And so the proportions are skewed. It's difficult to come up with an accurate guess about the true proportions and the relative difference between these 2 values because of the fact that that y-axis has been truncated, commonly pointed out, and so almost ad nauseum and maybe even eventually annoyingly so. But there's some value and there's some validity to this problem that people love to bring up, which is that the y-axis can be confusing if it's truncated in this way. Now, I don't ascribe to the belief that it can never be truncated. I think there are some examples, but I will admit that they are probably rare, at least if your goal is to communicate accurately, which is typically very important. So let's look at some more bars. This one came up recently, and it's talking about violent crime in New York City. And you can see the chart here showing that there seems to be a rather large increase in 2021. Now, this was tweeted out by the New York City comptroller, I think, named Brad Lander. And he snarkily remarks that it's the largest 7.5% increase that we've ever seen. As you can see, it's labeled there to the right. And again, the same issue here. It's a little harder to see because a screenshot includes a caption sitting over the top of it. But if you were to look closely, you'd see that it goes to 92,000 as opposed to all the way down to 0. And so again, same issue here, right? Now, many people that I noticed on social media jumped to the conclusion that this was intentional and, fairly malicious and devious on the part of the organization presenting it. And well, that might be the case, but I really have no idea. So I'm not going to comment on their intention or motivation at all. But what I will simply notice is that I wanted to recreate this chart as I did before to show you what the true change looked like. But when I put these numbers manually, typing them into Excel, and I went to go create a bar chart, by accepting the recommended chart in Excel, I noticed that that's exactly what I got, a bar chart with a minimum value of 92,000, as you can see here in the middle view, and that goes all the way up to 104,000 violent crimes, which is exactly what we see in the view here. So it's also plausible that maybe they simply accepted the defaults of the software, which we can argue are probably not ideal. But in any case, that is important to note that there could be a variety of reasons why someone has created a chart maybe it is sort of giving a skewed perspective that is in their favor or backing their agenda. And so that is true, and we can note that. But again, whether that was purposefully lying or misleading or not really sure. At least, certainly in this case, I did not watch even the video or have any idea really about the context other than just what I saw on social media. Another cautionary tale too. It's easy to jump to conclusions based on a single snippet that we see or we come across. Sometimes it's good to look deeper into the context. Speaking of context with this exact example, and by the way, this is the example I wanted to talk about where we are talking about people whose lives have been tragically ruined and ended because of what's happening in New York City and places all around the world. And certainly, it's on society to figure out how to move forward, how to use data as a potential solution and cure of that disease rather than being a part of an entirely new disease, perhaps, where these problems end up getting worse because of how the data is being leveraged by various organizations, perhaps, and that's certainly possible. But this question about context is important because it might be that the way in which this chart is misleading has nothing to do with, or certainly less to do with, the y-axis as another important detail, which is the context. So maybe we can go and look at more data going back farther in time. And also, I would make the argument showing it as lines instead of bars. Here's examples of some research by Tversky. I mentioned her book, Mind in Motion, where she shows through some of the research that, it is true in general that people tend to associate lines with trends, change over time, and bars, on the other hand, are really better used for discrete comparisons. Like if I take these two examples, on the left, you're comparing one versus the other, apples versus oranges. On the right, your mind thinks to trends or changing over time. So here's that same New York violent crime data in a line that goes all the way down to 0. You can see there's definitely an uptick there. It's certainly not as dramatic as the bar made it look. While they did call out the percent change in the label, I'll give them credit for that. Certainly, if we look at it this way, we can see that, it is not quite a dramatic increase. But maybe more importantly, what if we go farther back in time to 2000 and look at the last 21 years of data, 22 years of data actually, and get a little more context? Then that's where we see this is the same data. Now, the data shown is only over here to the right. But if we go back in time, we see that really, crime, certainly with these, as it's measured and recorded and reported, has been going down over the past couple decades in New York City. Also, this uptick at the end, there could be a variety of reasons for that. It could be that it's measured differently or some procedures changed. Could be that maybe some different equipment or processes are being leveraged in order to keep track of things. Could also have something to do with the fact that a lot of people moved back into the city in 2021 after that first year of COVID, and the mass exodus that it saw there perhaps subsided somewhat. So, a lot of things going on here, right? A lot of context to be included in the conversation. And that, again, might be an important thing for us to consider. Okay, another bar chart that is a bit misleading, and this is maybe a technicality, but I think it matters. We see this bar chart about GDP growth, don't we? Now, if you look very closely, you notice that the y-axis kind of telescopes at the top. What do I mean? Well, the grid lines are all 1.0 until we get up here, and then it switches to 0.5 and 0.5, meaning that top is extended by one whole line. And that is only influencing the white bar to the far right. It's the only one that extends into that region. And so it gets stretched a bit at the very top. And you might say, oh, that's such a small technicality. And I would say, yeah, it's probably not a major deal. It does exaggerate it somewhat, maybe even accentuated by the presence of that call out icon up here, this, you are here type icon, which makes it look maybe even a bit bigger. So let's look at what this data looks like from the New York Times publishing it. If we get rid of that y-axis funny business, as I call it here, it's still a big increase, thankfully, but not quite as big. Also more time we're looking at here. We can see it in context of additional increases in GDP. But what we need to appreciate is that this is also, and maybe again, more importantly than this small detail with the y-axis, is the fact that we're talking about change in GDP, right? Percent change, not change itself, not GDP itself. And so what do I mean? Well, if a value, like let's say 100, if it decreases by 50%, then it goes down to 50. But if that next value increases by the same percentage, 50%, it does not go all the way back up to 100, does it? 50 increased by 50%. Well, half of 50 is 25. We add that back on top. We only get back to 75, meaning a drop followed by an increase is different because it's on a different base. And so that's the story here, that we saw a major drop and then we saw another massive increase. Thankfully, really, that this is the way it has gone for us in the world since COVID in 2020. But the point is, when we're looking at change, we should probably also look at the value itself. Here is the same data, not the change in GDP, but rather just GDP itself. And we can see that there's the downtick, there's the uptick. And maybe more or less that uptick got us back on track for where we were already going, up until and prior to the pandemic hit. And so, this tells a slightly different story, maybe not one that's as dramatic and exuberantly exciting, but certainly is still a positive story. Thankfully, it could have gotten a lot worse, really. So again, thinking about things from a few different angles can give us a broader perspective. Well, I see this a lot, and well, I don't mean to poke fun at people, but there is certainly the case that politicians do tend to exaggerate the views. We can find people all over the spectrum in every country doing similar kinds of things. On the left is a politician, I believe from Hungary. You can see his bar or trapezoid maybe, of 33% is quite a bit larger than his, I guess, next opponent, 26%. But that's a rather large drop, isn't it, for just a small 7 percentage points decrease. Also over here on the right-hand side, the top bar published by that specific politician is quite a bit larger than the next person in line, although there's only 1.5 percentage points difference between them. Quite a bit, really the same visually in terms of increase in length as you see when you go down to less than half of that value. So some skewing happening there for sure. This one I saw, it's a while back. Again, no comment about really the politicians themselves, what they stand for, who they are. Just completely leave that conversation for another day. But simply looking at the graphic design itself, we see that, well, this bar here, which is actually an arc, has a lot more area to it than the one below it. And so it makes it look like it's quite a bit larger when you can clearly see it's a smaller value, So there's some graphic design techniques that are being used here to present maybe a rosier picture than what exists. And so, just again, see those kinds of things. And I don't know that necessarily those are interesting or, well, they're interesting, but I'm not sure if they're the best approach because, there's already enough maybe mistrust of politicians that I think it would probably behoove them to present the data in a way that seems as clear as possible. And, I get it. They're trying to win votes. They're trying to present a very strong and attractive kind of a view. But in any case, I think this is playing with the data in a way I probably wouldn't recommend doing because he was behind by 4 points here, where the bar here, this arcing bar, is quite a bit larger. So again, leaving aside whether you like one or the other or not really this topic today. I did like this one by Alex Selby Boothroyd. He shared this on Twitter. What I like about it is his witty comment. He's just a really funny person. I love following him on Twitter. He makes these dad jokes all the time that I really appreciate, being a dad myself. But he talks about this GDP, again, back to GDP, bars. And what happens when we get to the bottom here? Well, the flag switches sides as the value goes from negative to positive, but the red Chinese flag here seems to be one of the bars in the line, doesn't it? And what I love about it is Alex called it a red flag. So there's a double meaning there, clearly, which I really appreciate. So kudos to you, Alex. You got me to chuckle there. But again, what is this? A graphic design technique, probably not intended to mislead anybody. Just simply a choice they made about where to put the flags that might fool a few people. Okay, type number 2 is all about color. Color is such a double-edged sword, so powerful, but also so easy to get wrong and to cause confusion. So color me confused, that's our category number 2. This one was shared by a student of mine at University of Washington's MBA program at Foster School of Business. These are baseball teams, and they've chosen to color their bars based on the uniform of those players that play for those teams. But the bars themselves are more related to the legend over here, 1, 2, and 3, as I can guess. I might be wrong, but I think that's probably right. That number 1 here is the first bar, number 2 is the middle bar for each team, number 3 is the third bar for each team. You can also verify that by seeing that they probably add together to get to that 3 overall. But again, we're adding colors here in a way that maybe is fun and interesting, and evokes the feeling about the team and how they how their uniforms look, but it isn't really conveying a lot of information connected to the data itself, or certainly not the values themselves. And so an interesting use of color, an attempt to try, I think, to make it more graphically interesting, but maybe a risky one. Again, you might have your opinion. This is probably intended for an audience that is incredibly also very knowledgeable about baseball, based on the blog post there and the URL you can see. So my guess is, they're speaking to an audience that is really familiar with these uniform colors, whereas, you or I or someone else out there might not be, but that might not be their audience. So we'll leave that one aside. This one about colors, well, the more you look at these lines and the legend to the right of it, no matter who you are, you're going to struggle. In fact, you probably will get more and more confused. So the choices here, 50 different colors, pretty much all in shades of blue or green or red. Again, not enough differentiation there. So it's going to really confuse people and not what you probably want to do there. Here's a simple example that's, well, unfortunately, the only female here in the slide, her bars are completely hidden. And so there's an example of hidden figures, a reference there to some very influential women of the 20th century. And so a graphic design choice here to put a background color that sort of obscures or makes it very difficult, at least, to see the bars at all. So quite a big problem there. This one was shared by another one of my students recently. I don't think I've seen a chart that devotes so much real estate to the legend. So this is video game operating systems over time, how popular I think they are, or how much utilization of those operating systems that has been seen. And so, there's lots of colors, they all overlap. They're not really adding a lot of value other than expressing that there are a massive number of such operating systems. And maybe that's the goal. And so in that case, this is effective. But other than that, I would say, choosing this many colors and trying to show them all when many of them are so incredibly tiny doesn't really give value to the view. I would make the argument the only ones that are really of value are the ones that are labeled in the area chart there, the stacked area chart. We talked about this in the class, and then really kind of appropriately, and it's so funny how this happens, but the very next day, a blog post was published by the very talented Lisa Charlotte Muth at Data Wrapper, and she talked about ways to handle exactly these situations. I totally agree with Ali Torban and her reaction that this was gold advice. That's definitely the right color. Exceptions to every rules. Here's an example where using all those colors isn't just appropriate, it is the point. So this is by Stephen Wagner, I believe. And so this is showing the color changes in crayons over the years, over the decades, actually. And so the colors are the story. So we wouldn't want to make any of them gray or combine them in any way. That is the story. And also, and this is what we call in the classes a natural mapping, where the data itself is connected to something in the world itself. Like if I were to show you a chart about soccer players' heights, I would probably show those bars being vertically as opposed to horizontally, because we compare people's heights when they're standing up. So making it as close to the real thing can be helpful for that audience. Speaking of natural mapping, sometimes the colors in a chart are showing colors of something and those aren't matching. So why would you show shoe colors if those shoes are black? And you would probably not want to show that green bar for black shoes, nor would you want to show a blue bar for white shoes, and so forth. You would probably want to match those, right? Have them be one-to-one with the colors themselves. But if all you did was import it and use the software defaults, as we see on the right, well, they're going to line up probably maybe alphabetically or something like that, and they're not going to be necessarily the same colors. Okay, type number 3. This one I call disorder in the chart. So order is such an important detail when we show visualizations. And so here's the example from the CDC. It's talking about life expectancy by state. And I'll just ask you to say, to yourself, well, which are the states that my eyes go to first, or which are they drawn to? When I presented this live in the webinar, most people mentioned the blue states, okay, that are here. And so there's a problem with that, and we're going to come back to that. First, I just want to kind of give a quick overview of an important concept, which is that When we talk about variable types, these are the columns in our spreadsheets and the attributes in our databases. There's different kinds, as Stanley Smith Stevens outlined way back in the 1940s. And of these four, only the nominal doesn't have an order to it. This would be like fruit type, apple, banana, pear. All the other ones, including ordinal, even though it's categorical, the ordinal scale type involves levels that belong in an order by definition. So like Olympic medals, gold, silver, bronze. And then of course, quantities go in an order because the numbers are either greater than or less than each other, as long as they're not the same number. Okay, so we use the analogy of noir and the acronym there to help people remember it. But the important concept is that researchers have shown or said, like, for example, Jacques McInlay, former coworker of mine at Tableau and a real data viz hero to me, that you want the chart and the encoding in the chart to express what's in the data. Well, when it comes to ordered data, you want to show ordered variables in a way that conveys that order. And you don't want to show or convey order if there is no order in the variable. Comparing, for example, on the right-hand side, numbers like 10 to 1 or days of the week, Monday, Tuesday, Wednesday, those go in an order. And so having circle area or circumference, I guess, getting smaller as the values go in that direction is perfectly fine. But using circle size for, say, like arbitrarily assigning a large circle to the eagle if your data was about bird types, and then arbitrarily giving a jay a medium-sized circle and a hawk a smaller circle, is not. The problem with that is it's expressing something that's not there. There is no order in that choice, but it seems like there is. Maybe another way of explaining that, if you were to show t-shirt sizes, small, medium, large, and you used icon area, that would do the trick. But maybe color hue wouldn't convey order in that same way. Or maybe a more ridiculous example would be to get the order wrong. And so instead of icon area, we'll say icon array, switch them around, small, medium, large. Probably not, even though gas stations seem to have no problem giving us these choices out of order for one reason or another. So order, it matters. I love this diagram by Munzner and Eamon McGuire in their book, Visualization Analysis and Design, that I referred to earlier. And they talk about this idea of expressiveness and effectiveness. The part of the diagram that captures expressiveness we just talked about is that these encodings on the left all have one thing in common. They tend to express the idea of order, whereas the ones on the right don't. Okay, so that being said, let's go back to that original example. Before we do that, though, the icons and their areas are on the left. That's an ordinal variable t-shirt size. It goes in an order. Using color hue is more appropriate for these unordered or identity channels. So our map, what was the problem with it? Well, look at the legend right down there. They don't really go in order. These bins and the bins go in order, but the colors don't seem to follow that order. It seems to get lighter, then darker, then lighter, then darker. So there's some kind of back and forth there. So if we recreate the data on the left-hand side here and sequentially make these shapes darker, we maybe are able to answer some questions more accurately about which states have higher or lower life expectancies. And that is great, but it might not answer all questions equally well. Maybe people want to know which states are above and below the overall US life expectancy in 2019, which happened to be 78.8 years old. That's including males and females together. Well, if that's the case, we would probably switch to a diverging color scale to see that and switch it. Make sure the color hues switch from brownish to turquoise. You can pick whichever colors you want. Although I would argue not red and blue in this scenario, since it's a US map, which would express, there's a notion of expressiveness again, the idea of political affiliation. But the browner the state shape is, the more less than the overall US life expectancy we see in that state. The more turquoise and darker turquoise it is, more saturation level of that turquoise, the higher it is above the US life expectancy, okay? Now, I noticed that this sort of problem happens a lot. This is another one that shows graduation rates. And if we compare Washington and Oregon, for example, it seems to be that Washington has a lower graduation rate because the shade is lighter, but in actual fact, it's higher. And it's the legend that switches that order for us. This kind of thing happens a lot. Here's another, well, there are exceptions to every rule. Like what about medal, Olympic medals? This is the Olympics happening right now. And so That's an example where, like I mentioned, it's a prototypical example of an ordinal variable that goes in an order, gold, then silver, then bronze. But we wouldn't really want to use color saturation to show them because the metals themselves are already a color. And so we would probably just use that. Many people are already familiar with that and associate value to those colors in the appropriate manner. So there's an example, right, of breaking that rule of thumb that even though it's an ordinal variable with an order to it, we still might use an identity channel because it's a special case. Whereas in general, those ordinal scales, yeah, you're probably going to want to be on the left-hand side over here, just not with this case. That's another example, again, of natural mapping. The metals have colors, so we stick with them. This one is a double whammy. So the state shapes show confirmed cases of COVID. Again, Washington kind of looking worse than it really is. It looks like it's the most cases, doesn't it, at first glance, along with Arizona, Colorado, Minnesota, until we look at the legend when we see that really actually the darker color here is associated with a lower level of cases than the lighter shade of red. And so again, a little bit misleading, right? The second problem with this one is very commonly pointed out about what we call choropleths or filled maps. And this is what GIS experts, which I am not, will point this out very readily, that this is just a population map. Which are the states then, once you recognize the legend, that have the highest number of cases? Well, California, Texas, Florida, New York. Well, that's no surprise because those are also the states with the highest population, the most number of people there. So for this type of data visualization, it's usually best to show rates, cases per person or per capita or something like that. This concept and this idea was really immortalized in brilliant fashion by Randall Munroe of XKCD, which you see here in this map. I'll let you read it if you like on your own, but basically these maps are just population maps, and that's something that I think that the previous example suffers from, both out of order as well as showing a quantity instead of a rate in a chart type where, that's not really ideal. Okay, last type, and then we'll wrap it up here. This one I'm titling Me See a Mistake. Now, there's an acronym. I know you probably already know too many, but here's another one. It's an important one. And I don't hear people in the data viz world talking about it as much as maybe I think they could. Now, there are certain chart types that express the notion of part to whole. The infamous pie chart, which people love to hate, but others too, stacked bars, tree maps, anything that gives a kind of an impression of a whole or a unit or a complete something. Every one of the marks are fitting together into some object that is itself kind of consistent and contiguous. And so the acronym to know is MECE, M-E-C-E. There's two parts to it, M-E, mutually exclusive, C-E, collectively exhaustive. The fact is that I find with part to whole charts, we really ideally need to be using individual segments of those charts that are MECE, mutually exclusive and collectively exhaustive, both, not one or the other, but both. Here's an example. What happens when we get that wrong? Well, if they're not mutually exclusive, you end up with a pie like this, where the slices add up to more than 100%. What do I mean they're not mutually exclusive? Well, this is showing what people are worried about. Biggest COVID-19 worries, but people can be worried about more than one thing, evidently. It's my guess. Check all that apply, kind of a survey, Yeah, I'm worried about getting it and my family getting it. I'm going to pick those two. I'm not really worried about the economy, so I won't check that one. That's the sort of scenario we're talking about, where picking one doesn't exclude me from picking the others, in which case these percentages add up to more than 100. This is another example that's confusing for a different reason maybe than it could otherwise be confusing. But, again, look at the percentages. They add up to more than 100%. This icon is not a pie chart, but it has the same issue, where baby boomers might describe themselves as many of these, more than one of them anyway. And so even though this is not a pie, it is an icon of a person, and these segments of this person add up to a whole person. And so it's kind of confusing that the percentages add up to more than 100% again. On top of that, I don't even know if they're proportional, but I'll leave that alone for now. So MECE. On the other side of that coin, CE, collectively exhaustive. So if we're showing a chart type like this pie that seems to indicate it's the whole enchilada, right? That's the whole thing. But then clearly you can see there are 15% of people that aren't included in here. When I say people, I mean probably poll respondents. Maybe they opted not to complete that question, or they say, I don't know, or I don't want to reply, or I don't trust either of them. I mean, there are other options here that are not being shown, even though the pie is very nicely kind of concise as one whole circle, which conveys the notion of completeness. Okay, so MISI, that's something we want to remember. Now, these four chart types, these four groups, rather, of gaffes, let's call them, are just a handful. There's so many more. It's important to us to be fluent in the language, to understand many of the different ways in which these charts can trip us up. This is what our level 1 course is all about, learning to see data. It's on demand. We also have a public course that's starting on February 28th, 2022, coming up in here just a little over a week and a half away, taught by the really talented Anna Maria Steverson of Netflix. Still room for that if you want to sign up for it. Or if you want to do the on-demand self-paced, you can do that too. Use the code GAFFESHAPPEN on our website, dataliteracy.com. That gives you 20% off. Feel free to spread the word about that. And, really dedicate some time this year to becoming fluent in that language. I think we all need to do it. And I'm happy to put this little webinar out there to kind of get the juices flowing and give you what's hopefully some helpful examples. Okay. With that, here's how you can get a hold of me. I'm Ben, as I mentioned. You can email me or reach out to me on LinkedIn or Twitter. Probably the best ways to get a hold of me. It's been a pleasure presenting for you today. Hope you enjoy it. Let me know in the comment here or reaching out to me directly what you think of some of these charts and if you know of others. And again, approaching this with humility.